For today, we will go for chapter 2 is on semiconductor diode and power supplies. I hope that all of you already have the notes. How many notes, set of notes do we have for chapter 2? Ni siapa nama dia? Okay, saya selalu lupa. Mukris, why do you wear round neck? Ada jaket? Tak ada. Basah. Tapi takkan tak ada baju yang ada collar? Saya tak adalah particular sangat, but then sometimes that is the regulations kan. Okay, kalau you jumpa dengan HCP ataupun bahagian yang suka saman tu kan, so you akan kena saman lah. Okay, alright. How many notes, set of notes do we have for chapter 2? 4. Okay, so chapter 1 is on the semiconductor and the diodes. In the chapter 1, this is basically more on the theory, because I want you guys untuk faham the fundamentals of the semiconductor, because we will apply in the diode. In the circuit, kita akan apply in diode. So you need to understand what is the operations dekat dalam the semiconductor first. Baru kita akan pergi on the calculations. Alright. So this is all the objective that we hope to achieve at the end of chapter 2. Okay, hujung chapter 2 kita akan hopefully you guys akan faham all these things lah. Okay, okay, basically for this one is on the theory, and this is hujung here, baru kita go for the calculations. Alright. Okay, first one, we want to go for the basic fundamentals of the semiconductor. Okay, have you heard on the semiconductor? Do you know what is the semiconductor? Mukris, what is the semiconductor? My previous class saya tanya what is semiconductor, dia jawab Intel. Betul tak? Intel is one of the semiconductors company kan? Okay, so still betul. Okay, company do products on the semiconductor. Okay, and for sure they have research on the semiconductor lah. Okay, alright. For the semiconductor, actually it is we have 3 types in the syllabus that we will cover. Okay, but then we have 3 types of adik-beradik lah, types of the semiconductor. Okay, we have the conductor, the semiconductor that we will focus, and also on the insulator. Okay, the conductors is the material that can conduct electricity. Okay, the current can flow easily in the conductor. Okay, we have satu barang atau one element, semiconductor, the conductor. Okay, from one end to another end, the current can flow because it is conducting material. Okay, highly conductivity. What is the types of conductor? What is something, benda yang when you ada electric shock, you cannot hold the things? Metal, yes. Metal. Lagi? Copper. Okay, bila kita do soldering, kita letak copper kan dekat kaki-kaki components. Why? Because the copper, even though kita guna as a, ni macam gum lah nak melekatkan the components with the breadboard tu, tapi it is can conduct electricity. So dia tak menghalang the current to flow. Okay, and aluminium, the gold, metal, inside the wire yang jumper wire yang kita tengok tu, the inside one is the conductor. Okay, and then insulator. Okay, the opposite from the conductor is the insulator. Okay, whose conductivity is very low, or basically it cannot conduct electricity at all. Okay, this is yang kita panggil penebat. Okay, when we there is electric shock, we need to hold the thing so that electric shock tu boleh stop. Okay, what other things, Mukris? Ah. Wood. What else? Girls? If you go to the lab, normally you kena pakai apa? Kasut? Yes. Rubber. Glass. Plastik. Kaki meja kalau besi tak boleh. Plastik je boleh. Okay. PVC. Plastik dah kan, dia PVC. Okay. Glass, kaca tu. Okay, that is all the things yang insulator. Okay, basically all our clothes pun sama lah. That is why kalau you pergi dekat lab ataupun you do high water and task, you kena pakai yang jacket ke safety jacket. Dia macam dia tebal sikit. Okay. So that bila dia tebal, kata kalau you ada orang terkena, orang pegang dia dia penebat kat situ lah. If it is very thin, bila kita pegang still kita kena juga. Okay. Alright, so that is the insulator. So we have by default two types lah, conductor and insulator. For these types of element, we don't have to do anything. Dia memang by default, it is very high conductivity for the conductor. Kita tak perlu buat apa-apa dah. And for the insulator, if we do anything for the insulator pun, dia still tak boleh nak conduct electricity. Okay, in the middle one, we have semiconductor. Okay, semiconductor, it can be a very good conductor or very bad insulator. Okay, depend on the process. We can do something to the insulator. Okay, kita nak suruh dia jadi conductor, then we put a process to the semiconductor so that it can be a very highly conductivity material. Okay, so that bila kita do a components, kita nak create one components and kita boleh jadikan dia as a very good conductor lah. Why we use the semiconductor rather than we use the conductor material? Because for the conductor, dia guna metal, copper, gold ke silver, that things pun can, but then it is very expensive. Kan? Metal kan mahal sekarang kan. Besi kat tepi jalan pun orang pergi curi. Walaupun besi berkarat. Kan? Okay, so that is why for the conductor it is very expensive and the sources pun susah nak dapat. For the semiconductor, it is very abundant in elements in the earth. So dia punya material tu senang nak dapat. That is why kita guna semiconductor. And for the semiconductor also, kita guna material yang the abundance resources also dia akan jadi very cheap lah. Okay, dia tak adalah benda tu mahal. Alright. Contoh dia, in our syllabus we only cover, we have three types: silicon, germanium and gallium arsenide. Okay, di yang bawah ni, the point bawah is the perbezaan in between. There is few characteristics. Okay, each of the conductors, insulator and semiconductor, it has different characteristic dia lah. Okay, that is how we can classify it is in the group of insulator or semiconductor or the conductor. Alright. So what is the semiconductor? Okay, has conductivity, it is in between, it is conductor lah, metals is the conductor, in between the conductor and also insulator. It can be conductor, it also can be insulator. Why? Because when we do a process to the semiconductor, it can conduct electricity. Okay. Okay, the example, we have three types: silicon, germanium and gallium arsenide. Silicon, germanium, normally kita tulis GE. SI is for silicon and gallium arsenide. Okay, for the silicon, only one element, and germanium one element. Gallium arsenide is two compound lah. Yang ni kita ada dua compound. This one you can relate with the chemistry yang you belajar in secondary school. Okay, periodic table. Okay, remember the periodic table. Macam mana kita nak dapatkan each of the group in the periodic table tu? Okay, depends on the element. In the we have the atoms, the electrons and holes. Okay, that is how we can group the elements in the periodic table. Okay, most commonly used is silicon and germanium, but then as compared in between silicon and germanium, silicon is most commonly used as compared to germanium, because silicon is we can make it from the silica, or if you ever heard on the pasir silica, okay, ataupun batu silika. So the resources is abundance on the earth. Okay, abundance element on earth, and it is very cheap lah sebab dia banyak kan, senang nak dapat. And germanium is more expensive to produce. Okay, silicon and germanium. Germanium lagi mahal sikit, and then silicon is a little bit cheaper. Okay, and other than that, in terms of the characteristic, the silicon is more stable to fabricate. Okay, it has a better properties for the silicon, and also has higher melting point. Okay, as compared to the germanium. Okay, and also it has wider band gap and higher electron mobility. Sekejap lagi kita tengok on the electron mobility, and you can relate. Okay, you can relate with the conductivity. Also, this is a very compatible and easy to fabricate lah for the silicon. That is why when kita jumpa the diode, okay, diode normally it is silicon, tapi agak jarang ada germanium, but then still we have the germanium lah. Okay, for the silicon, it has the voltage drop 0.7 watt. Okay, for the silicon. For the germanium, it is 0.3, yes, 0.3 watt. Okay, macam mana tahu? In EPE. Okay, very good. Okay. Alright, so we have the elemental semiconductor composed of single species of atom, and then we have the compound. So for the silicon and germanium, we call it as the elemental semiconductor because the compound inside is only one element. Okay, for the semiconductor with more than one element, we call it as the compound semiconductor. Okay, for the gallium arsenide tadi tu, it is the compound semiconductor. This one pun sama. All the materials yang ada more than one element, we call it as the compound semiconductor. Okay, for the compound semiconductors are widely used in high-speed devices and optoelectronic devices. But then, in terms of the cost, it is lagi expensive lah as compared to the silicon. Okay. What are the high-speed devices yang kita ada? Contoh, okay, for high-speed devices and optoelectronic devices such as we have the LED, in the small LED, laser diode, photodetectors and photodiodes. Every day you use. I think all of you sekarang ni might be tengah pegang that things. Apa? High-speed devices. Yes, your smartphone, smartwatch, your tablets, your device, the screen. Okay, and in the also dekat dalam kita punya cable, we also have the high speed devices inside that one, and dalam charger pun sometimes ada juga. Okay, for the in the labs, normally in the labs you use the oscilloscope yang ada screen tu, that screen, so that is also on the high speed devices. And fiber optics for communications, we have the transistors. Okay, for the CPU and microprocessor pun sama, we apply that one for the applications. And for the high speed memory device, contohnya, what are the high speed memory device? RAM, SSD card, DDR. Okay, yes. Okay, also dekat dalam we have in the solar cells. Okay, and yang paling banyak you akan jumpa dekat dalam electronic circuit is the IC, integrated circuit yang warna hitam tu, the small one. Okay, that is the IC, integrated circuit. Okay, for the medical field, okay, in the medical field also they apply for this semiconductor. Okay, kat mana? Bila you nak masuk universiti, you kena pergi buat apa kat klinik? Yes, X-ray. Cucuk buat X-ray pula. Okay, for the X-ray, okay, you do the X-ray, so they have that in the applications. Also dekat dalam when we do contohnya nak scan otak ataupun you want to scan the whole body, MRI. Yes, MRI. So in the MRI devices pun ada. Okay, in the automotive, also we have in the automotive, kat dalam kereta, in the electronic circuits, especially for now we have lots of EV car kan. So it has lots of electronic system kat dalam the EV car. Either in the engine control units used in the modern vehicles for the engine control lah. Okay, dekat screen kita in the electronic circuit dia pun sama. Alright, so basically for the silicon applications ni dia very wide, sangat luas. Yang paling hampir dengan you guys is on the devices yang selalu kita guna lah. Okay, so easy to relate. Okay, saya tak bagi contoh yang agak jauh-jauh sangat yang kita tak nampak. Okay, so senang you everyday guna, and you tahu okay benda yang you belajar kat mana the applications. Okay, alright. So this is on the, we want to go for the valence shell and valence band, conduction band. Okay, this is like the one that you learnt in chemistry kan. Okay, we have yang bulat-bulat, this one. Okay, this is untuk A is for the silicon. For the silicon and germanium, it has 4 valence electron at the outer circle. Okay, 1, 2, 3, 4 for the silicon. Okay, for the germanium also 1, 2, 3, 4. As you can see here the silicon dia ada lagi sikit layer lah. That is why it is easy to fabricate as compared to the germanium. Okay, ini lagi tebal lah dia punya layer. Yang bawah here is the gallium arsenide. Okay, each of the element has 3 valence electron lah. Okay, this one. Okay, the arsenide pun sama. Arsenide 1, 2, 3, 4, 5. Okay, so combine here we have 8 lah the electrons. Alright, yeah. No, tak perlu pun. No. That is chemistry. So for here, actually we want to go for the semiconductor. But then you need to understand on the characteristic first. Okay, baru nanti bila kita pergi on the how the current can be produced. So sebab saya nak explain on that, tapi kena pergi sejarah dia dulu sikit. Okay. Yes, mesti you rasa macam mengantuk banyaknya on the theory. Actually, soalan on the part A still boleh tanya on this part juga. Okay, some on the theory, the question can be asked also. Okay, so now we want to go to the conductions and valence band. I believe you guys pun dah biasa belajar. Pernah belajar lah this one. Tak adalah hari-hari belajar. Okay, but then you hopefully masih ingat lah what is the conduction band, what is the valence band. Okay, the conduction band is the EC, the valence band is the EV, and the in between EC and EV we have the EG, the forbidden gap or the energy gap. Okay, so EV is at the bottom, yang bawah, EC is at the top, and in between here we have the EG. Okay, so at the valence band we have lots of electrons. Now we want to go to how to get the current. Okay, current can be produced from the movements of the electrons. Like I have mentioned before this, movements of the electrons, we can have the current. Okay, so now we have lots of electrons dekat bawah ni. So what the electrons want to do is they want to jump from the EV to the EC. Okay, elektron nak lompat ni, jom kita lompat naik atas. Okay, tapi they face problems when the EG is a very large. Okay, very high. EC sangat tinggi. So dia punya gap in between EV to EC is a very large area. So dia tak boleh nak lompat. Okay, what we can do is we can reduce the energy gap. Okay, when the energy gap reduce, so the electrons can easily jump. Okay, when the electron can easily jump, so we can have the current flow lah. Okay. Alright. So this is kita tengok yang ni dulu. Overlap band. This one is for conductor. Conductor is easily the electrons here memang already can go to the conduction band. Because for the conductor, the current can easily flow. Meaning that the electrons can jump terus. In fact, dia tak perlu jump pun, dia terus pergi je. Because it has the overlap band. This one, we don't have the EG. EG is equals to 0. There is no gap. Okay, for conductor. Okay, this is when electrons can jump for the semiconductor. But then for the semiconductor can also jadi overlap band. Depend on the process that we do. Nanti kita tengok what are the process. Okay. If the insulator the electron cannot jump, so might be the EV and also EC, the gap is sangat besar lah, EG. So the electrons memang tak boleh nak lompat sangat jauh. Okay. Alright, so this is on the energy level. You guys can compare this one actually from the shells layer yang kita ada. So we have few layer. Contoh this one lah. Okay, so kita potong. It is actually, we have several layer, but then from each layer to another layer, it is actually one EV and yang atas is EC. So the EC yang atas tu akan jadi EV for the next layer pula. Okay. So this one lah. Okay, and from here dia akan pergi lagi dekat dengan nucleus. And yang hujung atas sekali is yang ada the electrons at the outer shell lah. So from each layer tu dia ada one EV, one EC. Okay, so that is how the electrons can jump from one layer to another layer. Okay. The insulator has a very large forbidden gap. Okay, this is on the normal value lah. Okay. But then it is actually for the electrons from one layer to another, from the EV nak pergi ke EC, we can disrupt also the process ataupun the conditions by increasing the temperature. Okay, temperature naik, the electrons can jump also. But then kita tak boleh nak simply naikkan the temperature, nanti habis dah terbakar our components, kan? Okay, that is only for at a certain value of the temperature sahaja the electrons can be excited and jump to the conduction band. Okay, on a certain temperature. Okay, semiconductor materials increase in temperature. Okay, the EG decrease, meaning that we can buat the EV and EC lagi rapat, so that the EG decrease and then the electrons can jump. Okay, that is one process lah. Okay, by increasing on the temperature. Okay, kenapa, why we want to make the electrons jump from the valence band to the conduction band? Why? Because we want to get the current flow. Yes, we want to get the current flow. Okay, by one process is increase the temperature, tapi tak adalah nak increase sampai hari tu yang dekat Putra Heights apa 1000 degree Celsius. So tak boleh lah, nanti habis cair semua benda. Okay, so the second process that we can do is by adding impurities. Okay, we add few elements ataupun one or two elements so that the pure semiconductor, it is not pure anymore. Kita tambah elemen dekat dalam elemen dia. Kita tambah bendasing. Okay, we add bendasing. Okay, this is movements of the electrons lah. Okay, electrons nak lompat naik atas. For insulator, kalau tadi more than 3 EV. Okay, for the semiconductor, this EG can be reduced so that the electrons can flow. For the conductor, there is no gap. Okay, this explanation sama macam tadi. Okay, so one process is we can add the temperature lah. We increase the temperature. So due to the increasing temperature, and the electrons can get excited and then move to the conduction band. Okay, one more process is we can add impurities. Impurities is a bendasing. So we can add a 4-range element to the pure semiconductor. It will be not pure anymore lah. The pure semiconductor, we call it as the intrinsic. Okay, here intrinsic is the pure semiconductor. Okay, has a very low level of impurities or no impurities at all in the intrinsic. And then the intrinsic, we go for a process calling the doping process. Okay, doping process, the process where we add 4-range element to the intrinsic, to the pure semiconductor. Okay, and then the pure semiconductor will become extrinsic. Yes, doping is the process adding impurities. Okay, what is our purpose? Tujuan kita apa? We want to improve the conductivity so that the electrons can flow, electron can jump, current can flow. Okay, and then the semiconductor will become conductor. Okay, or we call it as the highly conductivity semiconductor. Okay, the process is doping, add impurities to the intrinsic, and then it will become the extrinsic semiconductor. Okay, we add impurities or benda asing. Okay, and then the benda asing, the impurities, it is dopant. Okay, we add dopant to the intrinsic during doping process to get extrinsic. Dopant is the bahan. Dopant tu benda asing. Okay, benda asing is the impurity. So benda yang sama lah. Okay, boleh tak? DOPANT. Dopant. Okay, alright. So that is the difference between intrinsic and extrinsic. Okay, intrinsic can become extrinsic by flowing few process lah. Okay, the doping process. Okay, this is the explanations on the intrinsic. Can be classified into intrinsic and extrinsic. The question can be asked, what is intrinsic? What are the process from intrinsic to become the extrinsic? What are the element that can be added? Okay, what are the names of the element? Okay, dopant lah. Alright. And then it is actually for the dopant that we can add, it is either we add electrons or we create holes. The process lah. Okay, in the process, electrons hole pair generations. Okay, because actually we want to make the energy band gap lagi kecil. So we add electrons so that the electrons can jump easily juga. It is depends on the number of electrons and hole. Okay. In order to get the extrinsic, kita kena tahu what are the purpose. We want to get the n-type or p-type. Kalau nak dapat n-type, kita tambah the electron. If we want to get the p-type, we create hole. Okay. Macam mana nak create hole? By adding down some elements lah dekat dalam proses, in the doping process. Okay. And here is the explanations of the extrinsic. You guys boleh baca in here. Okay, adding small amount of orange element called the impurities, because the electrical properties we can alter. Okay, that is our purpose lah. We want to alter on the electrical properties. Okay, so now we are in the process of doping. Okay, process doping kan, we want to create on the extrinsic. Okay, so from there we can get the p-type and n-type semiconductor. Okay, we have two types of impurity added. Okay, it is actually depends on from the group of periodic table lah yang you guys belajar. Habis rosak tudung saya. Tak, meja ni dia berbulu. Dia merosakkan kain. Okay, alright. So the periodic table, we have to get the n-type. Our purpose is to get n-type or p-type. Okay, for the diode. Okay, it is either we add electrons in the conduction band or create holes in the valence band. Okay, for the conduction band, if there is lots of electrons, so dia akan menarik lagi electrons yang bawah. Okay, for the valence band, we create holes to get the n-type and also or the p-type. Salah satu je lah. It is either we want to get n or p. Okay, this is for n-type, and for the negative charge or the majority if negative electrons, negative ions for the majority. Okay, for n-type. We are not going to go details on this one lah. Okay, dia punya components dia. This is more to chemistry. Okay, for the n-type, this is also the process. Okay, depends on the electrons lah, covalence bond and so on. Okay, that one we call it, dia akan dapat donor impurity for the n-type. Okay, when we add electrons, say from the EC yang dekat atas, okay, this is EV. Okay, so now we will create the donor, we will have donor ionization energy. Okay, this is when we adding elements of the electrons. Okay, so we want to get the n type. If we want to get the n type, dia akan jadi ED tu lagi rendah. So might be lagi rendah lagi pun boleh. So the EG is, we will get smaller EG. Okay, so the electrons can easily jump and then we can have current flow lah. Okay, this is kalau if we want to get the n type. Okay, what will happen if we want to get the p type pula? Okay, P majority charges is the positive charge. Okay, this one okay, kalau tadi we have the ED here, donor excitation energy, for the new EC lah. Okay, for the P type, yes, P type we can increase the level of the EA. Kita naikkan level EA pula. So the EG pun will be reduced. It is either two way. Okay, we decrease the level of the EC or we increase the level of the EV. Okay, depends on what are our objective. If we want to get the N type, so kita turunkan the EC. If we want to get the P type, kita naikkan level of the EV. Okay. Alright, so faham kat sini until here? So ini adalah, it's like sejarah how to get the P, how to get the N. So now we already have one type of P. We already also can get the type of N. Okay, from the semiconductor yang asal kita ada tadi. Okay. So now what will happen if we have the P and N, we put these two together? Okay, we put the positive charge and negative charge together bersama-sama. So due to the different polarity or different concentration gradient. Okay, kita akan ada proses kat sini. Semalam saya bagi contoh when we put orang PAS and orang BN. So dia akan jadi konflik kat situ. Okay, so now we want to study on what are the conflict that will happen if we put these two elements yang berbeza together. Okay. Alright, so now nanti you guys akan tengok juga why we call it as the junction. Okay, the PN is comes from the P type and N type lah. Okay. Okay, the term junction refers to the boundary. When we have one type adjacent with another type, P type, what are the majority carrier for P type? Positive charge. So majority dia adalah positive ions. Okay, for N type, okay, electrons, so negative. Okay, so for sure because we put positive and negative majority carrier together, dia akan ada something kat tengah ni will happen. Okay, yes, the term junction refer to the boundary between two semiconductor region. And then the PN junction, we call it as the PN junction diode or the semiconductor diode. So this one lah actually the diode. Okay, the symbol is like this. This is positive, this is negative because here is positive, negative lah. Okay, so this is the diode. Yang 0.7 tadi tu for the silicon or 0.3 for the germanium. Okay. Alright, so this one. When we have the P type and N type. So in between here, okay, this one. We have the space charge region. Because these positive ions will attract this one to here. Dia nak pergi situ, so dia akan berkumpul kat sini. Meanwhile, for the negative ions majority here, okay, dia akan menarik this positive here and then berkumpul dekat sini. Okay, so in between this one, we call it as the space charge region. Okay, the space charge region.
Space charge region boleh produce macam electrical spark tak?
Yes. So the electrons will move to here. That is how the current can flow lah. Okay. We also now kita nak pergi lagi deeper. So sekarang ni kita dah ada space charge kat tengah due to the perbezaan positif negatif kan. Okay, so now the space charge region can be reduced ataupun can be increased. Dia boleh jadi lagi luas ataupun lagi sempit, meaning that there is like no region dah kat tengah. Okay. You guys boleh baca kat sini. Alright. So the movements of the electrons, this one kat dalam here, by default when we put these two majority concentration difference berbeza tu, we can have movements of the electrons. Kita tak perlu buat apa-apa, movements memang automatic will bergerak. Okay, and due to that we can have the diffusion current. Okay, the electron will diffuse to P region from N region. Okay, so the diffusion electrons can produce diffusion current. Okay, but then the diffusion current is a very small amount. So sometimes kita tak boleh nak measure pun sebab value dia sangat kecil. Tapi we know there is a diffusion current due to the movements of the electron. Okay, electron move daripada N type to the P type. Okay, due daripada from N dia pergi ke P. Okay, and then we can have the diffusion current. Okay, that is the first current yang ada lah. Okay, in the PN junction. Okay, the second one, when we have, contoh macam ni, mana tadi gambar? Okay, here kita ada region. Okay, second one is bila we want to disrupt on the operation here. Okay, kita nak tambah the external electric field. Kita nak tambah external battery ataupun charges. Okay, for this one, this is negative. So here is negative kan. From here is positive, dia akan jadi positif kat sini. So from the positive and negative yang baru ni, what will happen? Since kat sini is negative, negatif yang besar daripada charge kat sini, let's say kita letak 10 watt ataupun 7 battery, 3 watt ke 3 watt battery, kita sambung with the 3 watt lah. Okay, 3 watt battery. Okay, so this negative, dia akan negatif dengan negatif will be okay, repel. Dia akan tolak kan. So dia tak nak kawan, dia akan pergi. Jangan kawan dengan negatif, kita pergi belah sini. Ramai-ramai the electrons will move here. So kat sini akan kosong lah, sebab dia banyak pergi tolak belah sini. Kan negatif and negatif. Same goes this one. Positive and positive, dia akan bertolak ke tengah. Okay, sebab dia kata belah sana lagi banyak positif, kita kawan dengan positif sana. So the ions of the electrons tu, the negative carrier, dia akan move to the center. Same goes with the holes. Holes dekat P pun akan move to the center. What will happen when they move to the center? The space charge region yang tengah tu, dia akan jadi macam ni. Sebab semua nak bertolak ke tengah dah. So it's like the space charge region reduce. Tak ada space dah. Okay, yang ni terbalik tadi. Yang gambar tadi kita letak P kat sini kan. Okay, so it just this one is the negative. So negative, so dia akan tolak. Positive here with positive this one also akan tolak, and all the majority carrier dia akan bertolak ke tengah lah. Dia lagi tertarik dengan negatif yang sebelah lagi satu. The positive yang red one akan tertarik with the negative. Yang negatif tertarik dengan positif here. Okay, so for this one we call it as the forward bias. Okay, in forward bias, since there is no region dah, no space charge region kat tengah, so the current can easily flow. Sebab dah tak ada region, so the current can flow straight away. Okay, so we have the value of the I, we can have the value of the voltage. Yes?
Jadi kalau kita terbalikkan bateri tu.
Yes, very good question. So now what happen if we tukar pula bateri? Okay, what happen bila kita tukar? This one is for forward bias lah. In forward bias, there is no space charge region. The current can easily flow. Yes. Okay. Okay. So what will happen if we change the polarity of the battery? You tengok the polarity here. Ini negatif sebelah sini kan. This is negative. This is positive. Okay, now we want to change the polarity. The other condition. Okay, the polarity here we jadi positive. So positive akan kat sini. Negative at the battery goes to the negative here. Lepas tu all the electrons dekat dalam N, kawan-kawan ada positif yang besar sebelah sana. Jom pergi. Sebab yang sebelah sini ini let's say kita letak 3. So dia lagi besar lah the charges. Okay, as compared tu yang dekat dalam here. So beramai-ramai akan bergerak ke tepi pula. Same goes with the positive yang the red one. Ada negative charge dekat hujung. So beramai-ramai goes to dekat tepi. Goes to the edge. So kat tengah we will have a wider space charge region or depletion region. Lagi luas jambatan yang tengah tu. And for this one, I is equals to 0. Open circuit, the current cannot flow. For this one, we call it as the reverse bias. Reverse bias is in off condition. The diode normally kita apply dekat dalam switch. We can use as switch. Okay, how to use as switch like this one lah. When we apply the different polarity of the battery, so it will become off condition. Okay, in the reverse bias. Reverse bias state, off condition, the current cannot flow. So maksudnya open circuit. Kan? Off lah, open circuit. Okay, for this one, for forward bias, the current can flow. On condition. We have the value of the I, the current. Okay, current boleh lalu. Okay, for on condition. Okay, close circuit. Kalau tadi open circuit, close circuit pula. Close circuit. Kalau tadi open circuit, this is close circuit. Alright. Okay, this is tak ada apa, just on the kat tengah ni lah if you want to baca lagi banyak. Okay, kalau on the open circuit off condition, so there is no current flow, voltage pun might be 0 lah. Okay, depends on the circuit juga. Okay, so this is untuk lukis for the symbol of the diode. Okay, positive for the P type, negative from the N type. This is cathode, this is anode. Okay. Okay, forward and reverse bias. This one. Okay, for the forward bias, this is forward bias. This is reverse bias. So forward bias, closed circuit. This is open circuit. So maksudnya dia boleh lalu lah. On. The switch is on. This one, the switch is off. The open circuit. If we have any element kat sini, ada resistor ke apa ke, since this one dia dah open, so I is 0, cannot flow. Okay. Alright, so this is the explanation macam yang tadi. On the forward bias and reverse bias, what will happen to the depletion of space charge region yang dekat tengah. You can compare lah. Alright. Okay, for the forward bias, the voltage drop in the diode must be greater than 0. We must have the value of the diode voltage. Okay. For the reverse bias, the value is equals to 0 or negative value. So we cannot, the current cannot flow. Okay. Okay, this is applications in a simple circuit for this one. So kat sini dia tulis silicon. What are the value? Sometimes dekat sini kita letak VD. Okay, we have the diode voltage. Okay, what are the value of the VD? Yes, for the silicon it is 0.7. So is if we have a circuit here, so the current can flow. So we can have the KVL. Kan? Okay, so the KVL minus E plus 0.6, kat sini plus kan?
Yes.
Okay, here is negative. The symbol of the diode. Okay, minus E plus 0.7 plus VD plus IR equals to 0. Or you can also write in terms of the voltage minus E plus VD plus VR equals to 0. Kan? So you can get the value of the current lah. Okay, in a simple loop like this. Okay. Macam ni atau macam ni. Okay, you can represent this one. Tapi in the circuit nanti, in your solution, you don't have to lukis macam ni pun. It just enough kalau you faham in the diode, if it is silicon, and then the VD here is 0.7. If it is germanium, it is 0.3. So you replace the value dekat dalam the your KVL lah. Okay. Now, what will happen if we have different connections of the diode? Macam ni. Here is negative, this one is positive. So, current must lalu kat sini sebab positif sini. So, what will happen to the I here? Dia akan jadi dekat hujung ni dengan sini, macam tu kan? And then I will be 0. Okay, open circuit. The current cannot flow because of the opposite polarity of the diode. Okay, diode is one component where only allows for one direction. One direction dia je boleh lalu, forward bias. Okay, but then we have another special diode that can allows for negative directions, reverse bias. We call it as the Zener diode. The Zener diode, we will learn on the Zener diode in chapter 2D. Nanti dekat hujung chapter 2. Okay, 2D. Alright, so for this one yang tadi, opposite polarity of the diode, sebab dia sambung macam ni, cannot flow, so the I will be 0. Okay, minus E plus VD plus VR equals to 0. Minus E plus VD plus IR equals to 0. So I is 0, so this one is 0. So we can have the VD equals to E. Okay. For this one, we can flow. Okay, get me the value of the I if ada tak? Okay, get me the value of the I here. Berapa value ID? ID, IR. Get me the value of ID, IR. Sikit. Dia punya meja dia dah dia macam ni. Dia semua macam ni. Hujung. Habis dah. Get me the value of ID and IR. Ya. Polarity of the diode in the positive, negative. So diode off meaning that diode is not function. Maksudnya it's like rosak ke kan. Macam kalau benda yang rosak orang nak lalu tak boleh dah kan. So dia off. Okay, so what is value of ID? Dapat berapa? Zul dapat berapa?
Belum. Tidak.
Belum? Macam ramai je tak datang ni. Everyone already sign? Belum sign? Cepat. Pendek je ni, simple je. Alright, minus 8 plus VD plus VR equals to 0. So minus 8 plus 0.7 plus I 2.2K. Simple je.
Saya dapat IR.
Tidak dapat.
Saya dapat 3.318 times 10 power of negative 3
milliampere. Okay, so IR?
IR tadi.
Okay.
Tadi tu IR.
Okay, itu IR. So ID?
Jika ID dengan IR sama kan?
Saya tanya ni.
Itu juga.
Okay.
Series.
Yang lain dia VR gitu.
Okay, boleh? Simple loop. This is the KVL. Minus 8 plus this is here is 0.7 plus I R. I darab dengan 2.2 equals to 0. Simple KVL. Okay, since it is one loop, so we only have one I lah. Okay, so ID is equals to IR. Series kan? Okay, yes, series circuit. Okay, this one here is one example when we change the polarity of this diode. Kita terbalikkan dia. Okay, so it is considered tak boleh letak kat situ. Okay, the diode is like this. Okay, negative, positive. So it is reverse bias off. Okay, the diode is off. Okay, when the diode is off, it's like open circuit lah. Dia tak function. So the current cannot flow. So I is equals to 0. Okay. This is cara tunjuk dia. Okay, so now we want to go for the load line analysis. Okay, for the load line analysis, this is a graphical method to analyze the operating point and the characteristic of the nonlinear electronic components. Okay, we will do the DC load line and IV characteristic graph. Okay, I want to go for the IV characteristic. It is I versus the V. I want to go for the, okay, this one first for the diode characteristic. Okay, we have the IV characteristic. When the question asks about the IV characteristic, it must have I versus V. Okay, for the ideal diode, this is for, alamak. Okay, this is for ideal diode. Okay, the ideal diode I versus V. This is kat sini sebenarnya. Okay, for the ideal diode. Okay, it is on the I line on the origin for the I and also on the origin for the V. Okay, but it is actually in practical there is no such ideal diode. Dia mesti ada value. Dia tak ada ideal diode sebenarnya. Okay, the first one is on the silicon. The silicon VD is 0.7. So the cut off voltage is kat sini 0.7. Okay, this is the IV characteristic of silicon diode. Okay, and this one here is reverse bias, reverse condition. This is for forward condition. Alright. So the second one we have here is the germanium. Germanium VD is equals to 0.3. So the cutoff is at here 0.3. Okay, for the germanium. Okay, the difference for IV characteristic silicon and germanium is the cutoff value lah. Okay, depends on the voltage potential for each of the component. Okay, so the next one we have, this is for Zener diode. Okay, for the Zener diode, this is the diode that can conduct electricity in reverse bias. Okay, so it has, kat sini is 0.7 cut off. Yang hujung here is minus 6.3. So it still can be operate in the reverse breakdown. Okay, nanti we will go for the Zener diode lagi deeper. What is the reverse breakdown? We have the avalanche breakdown and so on lah nanti. Okay, alright. So this one is for the load line analysis. Okay, this is yang biru here is actually comes from this one tadi lah, yang merah tu. Okay, this one contohnya. Okay, so we have this blue graph. Okay, that is the blue graph. So now we want to get the load line analysis. Load line analysis is actually kita nak dapatkan kat sini, dia plot dengan sini contohnya. Okay, how to get that straight line is the first point A and the first point B. The first point A, how to get this intersect when we need, kalau kita ada this this KVL minus E plus VD plus IR. Macam mana nak dapat the value at point A is kita set the VD is equals to 0. Sebab dia kat sini kan. So the VD is 0 lah on the straight line tu, on the intercept. Okay, for this at point B, how to get the value here? We set the ID equals to 0. This one is VD equals to 0. So dia terbalik. So when we have these two line, these two value kat mana nak plot for A and B, then kita sambung lah. Now we want to get the intercept here. The intercept we call it as the Q point. The Q point is very important because when we want to get the optimal point, okay, when we have one component, we want to let's say you are one of the analysis engineer. So you have one component, so you want to get the characteristic, or you want to create the, kalau kita ada satu component, kita ada dia punya sheet dia kan, sheet of the component tu. Okay, so kita nak tahu karakteristik dia. Okay, now we want to get the optimal point ataupun at the maximum point where the component is best operate. Okay, so the Q point is the one that we can determine. Kita nak dapatkan dia point, Q point, we must get the load line dululah. Okay, yang straight line is the load line. Okay, this one just study every characteristic. Okay, this is the load line and operating point. Load line is the straight line, the black one is the load line. We call it as the load line. And the operating point is this one, the Q. Dah tulis dah, the load line. Okay, the Q is the operating point. And the Q will determine at which point where the component best operate. Optimum point. The most, yang paling aktif, yang paling bagus dia nak operate dekat mana. Okay, one component ataupun satu jenis component might be different with another lah. Depends on the characteristic dia. Okay, let's say if we change the value of voltage, we change the value of the voltage supply. Contoh tadi 10, so kita kurangkan jadi 5. So it might be kurang ataupun lagi tinggi, kan? Same goes if we change the value of the resistor ke, so dia akan bertukar. So kalau dia bertukar like this, so the Q point is here pula. So dah tak sama lah. Depends on the circuits and the components yang lain kita adalah the value.
Kita main juga is the supply voltage.
Supply voltage, resistor value pun, yes. Okay, so the Q point is the best point represent where the line can be operate. The most active, maksudnya yang paling bagus lah. Okay. Okay, so this is the steps. Tadi ada dua cara lah. First one, because we want to get the two intersect point kan. So kita set V equals to 0 and also we can set the I of equals to 0. Okay. Ideal diode we can use as the switch. This one tak ada apa. Okay, contoh like this one lah. Okay. Okay, we have this the blue. Kalau that is why tadi saya explain dulu on the IV characteristic for the silicon, for the germanium, because nanti you akan tanya yang blue ni datang dari mana. Okay, how to get the blue graph tu. Okay, it is actually comes from the IV characteristic. Okay, so now we want to get the Q point. How to get the Q point? We must get the, kalau ada kat belakang Q is at the optimal point. Okay, VDQ is VD at the optimal point. Okay, alright. So first is we set the V equals to 0. So when we set the V is equals to 0, bila kita buat yang ni, kita akan dapat dekat sini lah. Okay, the intersect at the Y axis. So the intersect, the first intersect is kita dapat kat situ. So we just plot. Okay, and then the second intersect we for the KVL dia simple je, minus E plus VD plus IR equals to 0. So first is kita set VD equals to 0. When we set the VD equals to 0, kita akan dapat the value of I dekat mana kita nak plot lah. So we can have, for example, yang first kita dapat kat situ. Okay, the second one is when we set this one is equals to 0 pula. Okay, the I is equals to 0, so we can have E equals to VD kat sini. E equals to VD is the supply lah. Okay, so we can have the VD value kat sini. So we have these two lines, so kita sambungkan, and then our purpose to get this Q point. Once dah dapat the Q point, you just tarik, because now we want to get the IDQ. Okay, we want to get the value of the IDQ. So this is the value of the IDQ. Okay, VDQ is this one. VDQ just tarik IDQ dekat Y axis, IDQ tarik bawah at the X axis. Okay, so VDQ and IDQ we can get from this graph. What else? Okay, cuba kita tukar the value. If we change kat sini jadi 1K, kat sini kita jadikan 8 volt. Get me the new IDQ and VDQ. Sama je dengan yang ni, tapi the Q point might be berbeza lah. Okay, minus E plus VD plus IR equals to 0. So first is we set the kita nak dapatkan the E dulu. We set the VD is equals to 0. Okay, set VD equals to 0. Second, we set I equals to 0. The value, this one, E equals to 8, R change to 1 kilo ohm. Okay, for the first step, when we set VD equals to 0, I equals to R over E over R. Okay, what is the value of I? 8
8 maybe here.
8 milliampere. So kalau 8 milliampere somewhere sinilah rendahnya. Okay, okay. Alright, so now get the VD pula, V pula. When we set I is equals to 0, V is 10 kan? Sama, sorry, 8. Okay, so V is 8. So kita dapat that one. So you just sambung the 2 point. Alamak sangat, tak apalah. Okay, so just sambung the 2 point. This one V equals to 8. Okay, so just sambung the 2 point. So now we have the new Q point. This is new Q point. Okay, so from the new Q point, we want to get the IDQ. So you just tarik. So this one will be the IDQ. Might be dalam 7.5. Lebih kurang lah. Okay, sorry, ampere. 7.5 ampere. Okay, how about on the VDQ? New VDQ. Sama je kan? VDQ macam sama lah. Maybe 0.75 hingga 0.78. Lebih kurang lah. Kan?
Yes.
Okay. So this is how to get the IDQ, VDQ. And for the second question, nak dapatkan VR. Once dah dapat the I, you boleh dapat the VR lah. Okay. Alright. So it is very important for us untuk dapatkan the best Q point. Okay, Q point is the best point where the diode can be operate. Okay. Ni tak ada apa. I want to go to exercise sikit. Nak buat on the circuit. 9.30 dah. Okay, this one sama dengan yang tadi, yang kita dah buat the first one. This one is kalau the opposite polarity of the diode. This is a very simple. Saya tak nak buat yang ini sebab very simple. So the KVL is minus 12 plus, kalau both is silicon is 0.7. Okay, so minus 12 plus 0.7 plus 0.7 plus I 5.6K equals to 0. Itu for the first one lah. Okay, yang satu. Kalau yang dua, you just tukar the value of the D1 and D2. Okay, this is value of the VD1, VD2. Okay. Okay, this is the KVL, this one, dia akan lalu here, turun this one. Okay, the KVL is minus 12 plus 0.7 plus 0.3 plus I 5.6K equals to 0. Okay, the V0 equals to V 5.6K tu. 5.6K. I yang dapat darab dengan 5.6K. Okay, so this is the V0. V0 dekat sini. Okay, from the at the point of this one, connect until the ground. So the circuit also boleh lukis macam ni sebenarnya. Okay. Determine the V0 and ID. So ID is the I lah, sebab one circuit kan. So ID is the I value. V0 at this resistor. Okay, voltage drop at the resistor. Okay, so for this one, dia lain sikit this circuit. Minus 10 plus I 4.7K K plus 0.7 plus I darab dengan 2.2 macam mana tu? We have kat sini. How to do? minus 5 equals to 0. Okay. Why minus 5? It is actually kalau this part yang saya lukis balik, this one dia consider as connect macam tu, baru pergi ke ground, sebab dia negatif kat situ. Okay, how to determine? Sebab dia letak negatif. Let's say kalau connections dia buat macam ni, dia buat 5 je, so ini adalah the R. Okay, for this one, ini adalah sambungan kat atas dia tu For this one, kita consider as dia connect macam ni, baru pergi ke ground. 5 positif. Okay, so you must be very careful. Kalau soalan jadi macam ni, it is a tricky question. Okay, kadang-kadang you tak tahu, ataupun ada juga student dia tak ambil kira pun on the negative 5 watts in the KVL. So value akan dapat salah lah. Okay, so because we have the negative here. Kalau tak ada negatif, so tak apa. Kalau tak ada negatif, so dia akan jadi this one. If we have the positive, kalau positive 5, dia akan jadi macam ni. We have one battery kat hujung sebelum pergi ke ground, before we go to the ground. But now we have the negative, so dia akan jadi like this one lah. Okay, so in the circuit kita mesti minus 5. Boleh? Tapi dia simple circuit juga, one loop. Still one loop. Okay, so now we want to get the value of the dia tak apa, V2. Okay, the value of the V2, I darab dengan the R. Okay, dia tak masuk dengan minus 5 ni. Sebab V2 dia habis kat situ. If the V2 from here until ground, if the V2, the V3 lah pula, V3 IR minus 5. Sebab dia ada minus 5 kat situ. To get the V3, let's say we consider as kita buat loop dekat sini. Minus V3 plus IR minus 5 equals to 0. The loop lah. Minus V3 plus IR minus 5 equals to 0. If the V3 tu dia sampai ke ground, sebab hujung ni kan ground kan. Okay, so dia kena ambil 5. Kalau dia up until this point sahaja, so only at the respective resistor sahaja. If until hujung, still kena sambung with the minus 5 tu. Okay, tu beza dia lah. Okay, beza dia untuk you need to understand cara untuk baca the voltage sampai point mana. Okay, sebab tu saya kata kalau dia letak minus 5 macam ni, dia tricky. Alright, so apa lagi kita ada? This is sama je circuit biasa macam tadi. Okay, ni circuit yang tadi lah sebenarnya. Okay, sorry, circuit yang tadi. Please do, saya nak pergi lagi hujung sikit lagi ni. Okay, for this circuit, please do exercise at your own ya. Okay, so now we want to go for parallel and series. This one. This is when we have parallel diode. Ada dua. When we have two parallel diode, okay, kalau ada dua macam ni, this is 0.7, this one is also 0.7. Okay, if we have the same voltage of the diode macam ni, so the current will flow in both direction. Okay, in both connections, dua-dua the current akan lalu. We will have the ID1, also we will have the ID2. So the I1 is equals to ID1 plus ID2. Okay, why? Because we have the same voltage of the diode. VD dia sama. Okay, the problem here, kalau if we have the diode, satu silicon, another one is germanium. Okay, if we have one silicon and one germanium, this is 0.7, this one is 0.3. So the current nak lalu yang mana?
0.1.
Ha. Okay, current dah lalu sampai sini. I1 tadi. Alamak, I1 kata ada dua ni, nak lalu yang mana? The first one, yang ni lah. Yang ni dia akan on, the voltage akan naik up until 0.3 terus on. 0.3 dia akan on. Jom lalu sana, ada laluan. Because at 0.3 the diode can turn on. So all the I will flow sampai the sinilah. At this point, yang ini is off. Okay, so dia akan lalu dekat yang on dulu, yang mana voltage rendah. Okay, lagi satu condition is kita ada one diode macam ni, another one. Okay, so nak lalu yang mana pula?
Lalu yang positif.
So I1 kata kita nak lalu yang mana ni? Nak lalu yang first one ke nak lalu yang second?
Yang first.
Nak lalu laluan A ke nak lalu laluan B? Okay, so kat sini is I2, kat sini is I3. So what is the value of I2 and I3? Okay, so I3 equals to 0. Yes, very good. So yang ini pun akan off. Okay, ini yang tadi. Dia kalau voltage dia sama, silikon dua-dua akan on. Germanium both akan on. Kalau ada dua yang berbeza, dia akan on yang rendah dulu. Okay, kalau ada dua polarity, satu positif, satu forward bias, satu reverse bias, the reverse will be off juga. Okay. Okay, so for this one, which one will turn on? The LED. The green will on. What will happen to the red? Sebabkan terbalik. Kecuali kalau red tu kita pusing, red tu dia macam ni. Kena tengok pula dia punya red berapa value dia. Dia punya green berapa value dia. Kalau dia pusing red polarity, red akan on dulu. Okay. Ya. Kalau dua-dua polarity sama, kena tengok dia punya voltage. This one. Macam ni lah, bila kita tukar red dia jadi macam ni. This is yang red tu. Lepas tu red is 1.8. Dua-dua will turn on. Yes, both will turn on. Sama macam yang tadi punya condition. So for this one tadi, because it is off, consider as open circuit lah. So the current can flow this way sahaja. Okay, so can we do this one? Kita boleh buat KVL, simple KVL. Okay. Okay, for this one, which will turn on? So dia akan lalu, if we do KVL, minus 12 minus 0.3, lalu sini plus I 2.2 equals to 0. Okay. Okay, so this is one example lagi. We can do the KVL kat sini satu. And the current can flow. This one kena buat KVL macam ni. Okay. For example 3. Okay, so loop 1 minus E plus 0.7 plus 0.7 plus I 5.k equals to 0. So from here we can get the value of the I. Okay, for this is I2. Okay, for the I2. Okay, for this one pula, for the second loop, R1 plus 0.7 equals I1 R1 equals 0. Loop 2. Since this one dia bukan macam yang resistor. Kalau for the resistor IR, so the I tu kita kena ambil one loop tolak yang another loop kan. So this one for the diode, kita just ambil the voltage drop at the diode saja. Okay. So you boleh buat this example nanti. This one pun another one example. Okay, boleh buat. If you have any question on this one, this is considered as homework lah. Okay, nanti boleh, I will give the answer untuk this one. Okay, please do this homework. Boleh? Okay. Alright, so itu sahaja as for today.